Now we are finally done with diamonds. Let's move on to graphite. So, graphite is a natural crystalline form of carbon. It is grayish black, shiny, and a soft substance. If you are wondering about graphite, we talked about graphite before while we were studying about diamonds as well, right? So, this is what? So, wait, first tell me, where did you learn about graphite and diamonds? Well, I think you're right, definitely in the making of the artificial diamonds. So, coming back to graphite, graphite is a natural crystalline form of carbon, again, that it only and only has carbon in its composition. Okay, it is grayish black, shiny, and soft substance. It is slippery to touch, and it is found in Sri Lanka, Siberia, Russia, and India. In India, graphite is found in Jammu Kashmir, Bihar, Odisha, Rajasthan, and West Bengal. So these are the places where graphite are found, or graphite is found. Again, we don't know how true this is, but let's just go with what's written, right? Okay. So now talking about the preparation of graphite. Now, how is graphite exactly prepared? I mean, we all should know how graphite is prepared, right? So, graphite is artificially produced by heating powdered coke with a small amount of sand and ferric oxide in an electrical furnace at a temperature at about 3000 degrees Celsius. So, if you see 3C of coke, so this is definitely balanced as well. So, that's what I'm assuming again. So there is about 3C of coke. Coke is not the one we drink and not the thumbs up and everything. It's a different coke. It's a chemistry coke. So this coke is with sand and silica at the temperature of 3000 degrees Celsius, which gives silicon carbide and carbon monoxide. So this is how the preparation of graphite takes place. So what happens is, again, I'll explain to you guys well. So graphite is artificially produced. Again, artificially. So make this a term for you to underline and to make sure you don't get it wrong, right? So it is, what is it? It is artificially produced. Why? Because we are heating it at 3000 degrees Celsius. No one else is heating it. The volcano is not heating it. We are heating it. That's why it is artificially produced by heating powdered coke with a small amount of sand and ferric oxide. Why do we say ferric oxide? Tell me. That is why. That is because we either use that 3000 degrees Celsius or we use just silicon carbide in the presence of ferric oxide, which is heat, and it produces silicon and C, which is graphite, which is carbon basically. And carbon is graphite. Okay, so now coming to the structure of graphite. So graphite consists of layers of carbon atoms or sheets of carbon atoms. Each carbon atom in a graphite layer is joined to 3 other carbon atoms by strong bonds to form a flat hexagonal rings. So in diamonds, if you were seeing, right, what was the structure like? Do any of you remember what the structure was like? Well, the structure was like 1, 2, 3, 4, and 5. So one carbon atom was joined to 4 other carbon atoms. Well, in graphite, it's one less. One carbon atom is joined to 3 other carbon atoms with, again, very, very strong bonds. And this forms hexagonal rings. So hexagon looks like something like this. So it forms hexagonal rings. 1, 2, 3, 4, 5, 6. Again, all of these are definite geometric patterns. So 1 electrons of each carbon atom remains free. These free electrons make graphite. What do they make? They make graphite a good conductor of electricity. So the layers of carbon atoms in graphite are held together by weak forces. So over here, to sum it up over here and to make all of this very clear to you, so each electron of each carbon atom, it always remains free. Unlike diamond, and that was a disadvantage of diamond. Now we say that it is a poor conductor of electricity. Why? Because of the absence of the free electrons, right, in diamond. But in graphite, all these are in a free state. So they are in a free state, therefore what? They are a good conductor of electricity. Okay, and the layers of the layers of carbon atoms in graphite are held by weak forces, as definitely compared to diamond. So due to this weak forces, they slide over one another. This makes graphite a soft and slippery substance. So when we talk about why graphite is a soft and slippery substance, it is one and only because that the layers of carbon, the hexagonal rings, they are always held by weak forces, and due to this it's very soft and slippery. Okay, it's very soft and slippery, and that is why we say that, right? So there are strong forces over here. These are carbon atoms. Layers of hexagon, which I think you cannot see over here. I'll draw it for you. Something like this. Layers of hexagon. Or wait, 1 minute. Let me just draw a better hexagon for you. Yes, so this is a better hexagon, I guess. So there are 6 sides, right? So there are 6 sides, and over here, you see this, these are the weak forces, and that is why it is soft and slippery. And it always slips off here and there, it slides above one another, and that is why it's soft and slippery substance. Okay, let's go up now again. Now, let's come on to the properties of graphite. So the properties of graphite are, it is first definitely a grayish, black, lustrous and opaque substance. It is soft and slippery due to its sheet-like structure. Definitely. Its density is 2.39 gram by centimeter cube, and it has a high melting point of 3700 degrees Celsius, while diamond was 3500 degrees Celsius. It is stable to heat because of its strong carbon bonds, and it leaves a black mark on paper, definitely, because it's grayish black, right? So that is why it leaves a black mark on paper, and it's also very, since it leaves a black mark on paper, it is used in pencils, which you'll learn further when we study about the uses of graphite. Okay, and first of all, definitely it's a good conductor of heat and electricity, and it produces carbon dioxide gas when burnt in air. Because normally when burnt in air, substance or any other carbon substance, carbon containing allotrope won't actually produce carbon dioxide, or it won't be burnt. They need pure oxygen, but in this case graphite, if it's just left in air, it'll get burnt. Now let's get on to the uses of graphite. So first of all, it is a lubricant, as in graphite is soft and slippery in nature with a melting point, definitely, and powdered graphite is mixed with petroleum jelly to form grease. Grease is used in lubricant for moving parts of machines. So there's something called a grease which is used. So this grease, what is this grease used for? For sticking many substances and many parts of a machine, moving parts of the machine. So it is used as a lubricant, and it is very soft and slippery also, and it has a very high melting point, which makes it be used as a lubricant. Then it also has a use in electrodes, that graphite is a good conductor of electricity, hence it is used for making electrodes of electric furnaces. Now, as I said, it leaves a black mark on paper. That was one of the properties of graphite. That is why it is used in making black lines on paper, thus it is used for making pencil. Right? So we can easily sharpen the pencil lead. It is because the graphite layers slide over each other. Now get it? Why are we able to easily sharpen our pencils? That is because they slide above each other, and this is an important point to note. Then crucibles, that's graphite has a high melting point of 3700 degrees Celsius, and so it is used to make crucibles. If I'm not pronouncing it right, I'm really sorry. Then carbon brushes. Graphite is used for making carbon brushes for electric motors, and last and final, as a moderator, as graphite is used as a moderator to slow down the speed of neutrons in the muscular reactors. Now comes this great table which tells us the difference of diamond and graphite, and that is why throughout the lesson I was again and again mentioning that this was in graphite, this was in diamond. I was differentiating the properties. So this table will be really very easy for you now, if you were listening to me, which I hope you were. Okay, so the appearance of diamonds are transparent and have an extraordinary brilliance. Now, appearance, we're talking about how it looks, while graphite is black, opaque, and a shiny substance, as in it's lustrous. Definitely. Hardness, diamond is extremely hard, and graphite is soft and slippery. Why? Because of its weak forces, right? Density is really high, and this is comparatively low, but it's high. Okay, electrical conductivity, it's poor conductor of electricity, and this is a really good conductor of electricity. Now, the shape of the crystal is, it's a tetrahedral structure that repeats to form a three-dimensional octahedral structure, and this is a hexagonal sheet-like structure. Now, the burning of this, it burns in the air at 900 degrees Celsius to form carbon dioxide, and it burns in the air at 700 degrees Celsius to form carbon dioxide. So I hope you all understood this table well enough. Now, finally, the last allotrope of the crystalline form of carbon, which is fullerenes. So fullerenes are also a crystalline form of carbons, and a large number of carbon atoms are held together in a cage-like structure in fullerenes. They were discovered in the year 1985 by three scientists, H.W. Kroto, R.F. Curl, and R.E. Smalley. They were awarded the Nobel Prize in Chemistry in 1996 for the discovery of fullerenes. So this is just like a history of chemistry, which you don't really need to learn, but just keep this in the back of your mind. Because in MCQs they normally be like, when did they discover it? When did they get the Nobel Prize? So they got the Nobel Prize in 1996. Now they ask you, when did they discover it? They discovered it in 1985. So they probably may ask you, and probably who were the scientists who discovered fullerenes? So it was H.W. Kroto, R.F. Curl, and R.E. Smalley. Okay, so just I'll tell you a little trick. Okay, remember H.W. Okay, remember H.W. R.F. R.E. So let's take this. Ready? Hippo went, rode. Hippo went, rode, fun, rode, eagle. So hippo went, rode, fun, rode, eagle. Hippo went, rode, fun, rode, eagle. So hippo went, where did hippo went? Hippo went to Kroto. So that's your first scientist. Wait, let me just make this. Yeah. So hippo went. Where did hippo go? Hippo went to Kroto. Road fun. Where did the hippo have fun in the road? At Curl. And road eagle, the eagle on the road, he went to Smalley. Or he is Smalley. Got it? So this way, just keep this at the back of your mind, and I'm sure you all will get full marks, right? So fullerene has a fullerene containing 60 carbon atoms, that's 660, is called a Buckminster Fullerene. It is named after an American architect, Richard Buckminster Fullerene, who designed the domes similar to those of fullerene molecules. Carbon atoms are arranged in the Buckminster Fullerene. So what happened it? So a fullerene which has over 60 carbon atom is known as a Buckminster Fullerene. What is it known as? A Buckminster Fullerene. It is named after Richard Buckminster Fuller, however you want to pronounce it, because he designed the domes similar to those of fullerene molecules. So he was well recognized. So the carbon atoms that are arranged in the Buckminster Fullerene in hexagons and pentagons. So both six-sided or also five-sided. Okay, it can be prepared by the condensation of vaporized graphite in helium, and it is also found naturally in installer situated between stars, dust, and in some carbon-rich rocks. Now, as of the properties of fullerenes are of different colors. Okay, the color depend upon the number of carbon atoms present in them. Then fullerenes are more reactive than diamond and graphite. Their cage-like structure, okay, breaks on heating up to 100 degrees Celsius. So if you heat it to 100 degrees Celsius, the cage-like structure that it has, which almost looks like a football, right? It will break off. It will break off. So first of all, there are different colors. They're more reactive than diamond, and they are soluble in organic solvents. Their specific gravity is 1.8 to 2.11, and they do not conduct electricity and act as insulators. However, some of them act as superconductors at high temperature. Uses of fullerenes will be they're used as dry lubricants in cosmetics, and some compounds of fullerenes are used as superconductors, as also given over here. Okay, guys, so that's it from me to you today. I hope you all enjoyed my lesson and really understood on what this whole chapter is about. I also have a good news for you, probably whenever this video will be produced. My team and I will probably be producing a website on our channel, and I'm really excited for you guys, and for me it's a little surprise that I've been planning for all of you. So hope you all enjoy this video, and yes, bye guys.